Hello, this is Ben Zimmer from Enable Training and Consulting, and welcome to the next installment of the lvmastery.com tip jar. In this installment, we're going to talk about some common techniques and shortcuts which will make wiring your diagrams cleaner and faster, and we're going to talk about modularity. We're going to talk about modularity from 2 points of view. First, from the point of view of typedefs, and secondly, from the point of view of SubVIs. So let's begin now where we ended the previous entry, which is in the robot main VI of the advanced framework. Recall from the previous video that the robot main VI is the heart of the FRC advanced framework, and it's where all of the main SubVIs are called, such as begin and teleop. Let's go back to the teleop VI, where we're going to investigate some wiring techniques and shortcuts. I've had the opportunity to observe a lot of new LabVIEW programmers, and one of the most common problems I see is very simple to solve, and it's just about wiring techniques and wiring style. Let me give you an example. Let's delete and then redo the wire from the switch off time in the unbundle by name function to the bottom terminal of the comparison function. Observe how I delete the wire. I can click once and that will delete this wire branch. If I do that, then I'm left with this broken portion of the wire to remove. Let me undo that. If I double click on this wire, notice that it selects both portions of that wire branch, and so I can delete those in one swoop. Let me also demonstrate how a triple click can work. In this wire, we see that we have a connection from not just the terminal input, but to the unbundle by name and a second branch going to the case structure. So we can single click to select a portion of a branch, we can double click to select the entire branch, or if we triple click, that will select the entire wire, all of its branches. Now I don't want to delete this wire at this time, but for those of you who are making serious modifications or doing surgery on your code, you can find that doing the appropriate amount of clicking is going to save you a lot of time, as opposed to if you did want to remove this and you only deleted that one branch, then you'd have to repeat the process here. Now we don't want to remove that wire, so we'll just leave it intact, but I am going to remove the rest of the switch off time wire. And let's observe reconnecting this to here. I see a lot of new LabVIEW programmers simply doing this. Clicking once, dragging, and letting go on the second terminal. This isn't necessarily a bad thing in that the connection is correct, but if you take a look at this block diagram now, it's impossible to tell what's going on in this comparison function. So what might happen is you might take this and you drag it over, and then it's a little bit easier to tell. And then you might say, oh, well, it's a little bit ugly now, so I'm going to have to take this tunnel and move it down so that we don't have too many overlaps. Then you say, well, it's still a little bit out of whack. I want to add more wires later, so I'm going to drag this over. And maybe I will take this and move it over here so that it's a little cleaner. So let me undo all of those actions and show you how you can pin down a wire as you're creating it. The first hint is do not click and drag. Click once and release your mouse button. Now you've started the wire. What you can do now is pin that wire down anywhere you want. If I pin that down now, then it's automatically started a second branch which I can control. So I could simply go and put that exactly where I want it and observe that the tunnel has been placed in an appropriate location, and I don't have to go back and move my wires around. And it's a very common pitfall, especially when you're doing a lot of LabVIEW programming, to forget to go back and fix your wires or to do it all later, at which point it's going to take an awful lot longer. And you'll observe once you get quick at it that it doesn't take any longer to put the wire exactly where you want it than to just drag it directly from the source to the destination. I'm going to undo that again and demonstrate one more feature of this idea of pinning down a wire as you go. And that's the use of the spacebar. So again, I'm going to start with a single click, and I'm going to push the spacebar as I'm moving my mouse. So observe that this flips the orientation of that wire branch. And what that allows you to do, especially when you get fast at it, is to route the wire exactly where you want it and not have to worry about an extra pin down. The next tip I want to discuss is the control key. Now we know that the control key can be used to make a duplicate of an object by clicking and dragging while holding the control key down. But the control key can also be used to create more space on your block diagram. If you wanted to add space between the arcade drive and the gyro call, That could be done by pushing the Control key and dragging in an empty area of the block diagram. And you see what that does, it inserts space in your block diagram. You have to be very careful when you do this, because if you drag strictly vertically or strictly horizontally, it will only create space in that direction. But if you drag in a rectangle, it's going to move things in both axes. And if you've already taken great care to line up your wires and your objects, you can easily move them around into locations you don't necessarily want them when you create space this way. So my advice is try your best to only create space in either a vertical or horizontal orientation. The next topic I want to discuss is modularity. I want to use the example we created in the previous video, which is to use a gyro angle to set a servo angle with a little bit of logic and user data, such as the switch off time, to modify that behavior depending on some conditions. We want to take this example and actually duplicate it. So we're going to run this in two ways, with two gyros and two servos. So there's one way to do this, which would be simply to go back to the typedef and duplicate exactly what we did and put a second set of each of these calls. I'm going to show you a slightly different way, in this case which is going to be even more modular than before, and it's a really good use of the modularity of typedefs and also SubVIs within LabVIEW, and it can help you scale your code so that what works with one axis can work with two axes, three axes, or four axes with very, very little modification to your code. What I want to do is encapsulate this functionality and the data in such a way that it's easily scalable. So let's begin actually with the typedef. Go to our robot data and open that typedef. So here is our robot data typedef. Recall how we modified this in the previous video. We added the references to all the devices we needed to open, including the gyro and the servo, and we added this switch off time. So I'm going to make a modification now. I'm going to add a couple numeric controls. I'm going to add the gyro red angle, and I'm going to make a duplicate of that and call it the servo set angle. And I'm actually going to pull out the switch off time, because what I'm going to do is I'm going to encapsulate this within its own cluster and build a typedef of that. You'll see what I mean. So I'm going to go to the array matrix and cluster palette, put down a new cluster, and drop these objects inside. Then I'm going to modify that cluster by right-clicking on the very edge, choose Auto Sizing, Arrange Vertically. And I'm going to call this Pan Servo Gyro Data. Now I've created a cluster, I've put the data I wanted in it, but I haven't turned it into a typedef yet. Remember, in order to do that, we have to select a cluster. From the Edit menu, choose Customize Control, which is going to open that control up in its own window. And then from this palette, what we need to do is change it from a standard control to be a typedef. You can also choose Strict Typedef. The difference between typedef and strict typedef is that strict typedef insists that all of the appearance and properties of the controls be consistent, where typedef only insists that the data type be the same. You'll see the difference maybe if you're working in a dashboard type of application, where you want to display the cluster but you want to have exactly the same font, size, color, and so on. In this case, we'll just choose standard typedef and we'll save the control. Make sure when you save it that you save it into the same project that you're working on. You can always double check that by looking at the project name in the bottom left of any other windows. And give it a file name. We're going to call this the gyro servo data typedef. And when I close this, it's going to ask me if I want to replace the original control, the one that I chose Edit Customize Control on, with this control. And the answer is yes, I do. So now if I right click on this guy, we see that it also is a typedef. And what I'm going to do now is put him inside our main robot data typedef. And the whole reason for doing this was modularity. So now I'm going to take my control key, click and drag to make a duplicate of this guy, and naturally call the tilt.